next up will be me giving you a short overview on how OpenLABEL can play a role. So you should be able to see my screen now. Yeah. So yes, thank you, Nico. So the next slot is about what role OpenLABEL can play within the ASAM OpenX family. And let me start by giving you a short overview of what kind of standards do we have right now in that family, and where does that OpenLABEL fit in overall. So first of all, we have ASAM OpenDrive, which is a standard providing you a format to describe static road networks. Then we have ASAM OpenCRG giving you a format on describing road elevation data or surface elevation data or friction data for road surfaces, which is usually then used in vehicle dynamic simulations. Then we have OpenScenario, where we have OpenScenario 1.x, which is using an XML approach to describe scenarios. And then we have the currently still in the public review phase. So feel free to head over to the ASAM site and jump into the public review of OpenScenario 2.0, which is a description language for scenarios and which will cover a lot more features in the future to describe scenarios. Then we have the initiative of ASAM OpenODD, which where we released the concept paper on November 9th. And the goal of that project initiative is to create a format or language to formalize operational design domain specifications, so you can use them within your tool chain, make them comparable, and of course shareable as well. And then we have ASAM OpenLABEL, and I don't have to say many words about that because Nico already told you quite a bit about that. Then we have ASAM OSI, which is the interface to simulation. We have the OpenX ontology, which gives you pretty much the core domain model of the whole ASAM OpenX standards, and pretty much what they are currently doing. And they are already also in public review right now and targeting to release before the end of this year. They are defining the ontology and the terminology for all the OpenX standards. So all the standards will speak the same language in the end. As some of the standards have some legacy and quite a long development history before they were added to the ASAM standard portfolio, this caused a bit of divergence in between the terms and the concepts for individual things that were used. And that's why the OpenX ontology project is so very important. And then last but not least, we have currently a study project going on for test specification. And the goal of that project is to pretty much check, is there a need for further standardization project towards the scenario-based testing workflow? So how could that all of this look like in the future? And so now you got a little teaser of what this slide is going to look like. So pretty much we have our domain ontology described by the OpenX ontology. We have the operational design domain, which pretty much lives within that whole domain ontology, is using the domain ontology to define the operational design domain. And we have OpenDrive, OpenScenario, and OpenCRG to describe all these scenarios with their static and dynamic content for your testing or development workflow. And what OpenLABEL can do here now is pretty much access all of that data and add annotations to that data that is coming or is running in your simulation. And that hopefully would be then the same annotations as you would have them in the real world. And when all of this is annotated, we can and need to okay, so something happened. Okay, so and now pretty much with the ASAM OSI, you now can communicate all of that data to your simulation interface. To your simulation using that as an interface. So how could that look like? And I'm just having a short and simple example where we can see how you could derive labels or use labels with the other standards as well. So we have a simple T-junction where we define our road network on here. And I'm just going to keep that really short. So pretty much you have all your roads within that junction. You will attach lanes, and lanes will give you drivable areas you can definitely label using OpenLABEL. And that task will be similar in the real world, of course, because you want to know where your car is capable or should be able to drive, and also allowed to drive. So pretty much we have the paths through the junction, which are obviously all defined in OpenDrive. And apart from that, okay, animations within teams sometimes are funny. Okay, so pretty much what we have, we can define objects within OpenDrive, and they are positioned within the reference line coordinate system along the road, and we can derive inertial coordinates from them, and that will gives us also information on how would we label or would we need to label those objects in our simulation. And here we can see how that could help and how OpenDrive data could play a role and play together with OpenLABEL. Then we have, in this example, a few further road objects we can label using 3D bounding boxes, and how a 3D bounding box looks like, I can show you that later. And of course, here again, we have vegetation, we have a traffic light, we have, and here a road mark with a few special road structures, those speed bumps that in the use case of OpenDrive would be usually modeled by using OpenCRG patches. Yes, so, and if we go further into a scenario, we can say, okay, we have a few actors in here. We can label those as well, because OpenLABEL is capable of also adding labels to individual entities and objects, and you're able to label actions as well. So in this case, we would have a pedestrian, a truck, and a car, and you can see how they would move along. And now let's see if that works. Yes, so the car approaches, and you see how we would probably label that scenario. We are coming to the questions after that section, so please keep that in mind or use the chat to post it so we can run through them. And all of this can then be in the end labeled using OpenLABEL. And in the simple example of that speed limit sign, the JSON schema would contain the information. This is a speed limit sign 50. That's of type traffic sign. It is a quaternion, so it's a okay. So let me see. Apparently, I'm not sharing the screen.
I can see it, but apparently there's someone who cannot.
Yes. Let me reshare. Okay, hopefully it's better now. So what I wanted to say is that the schema that OpenLABEL is a JSON schema-based format. So we have the speed limit sign 50 here. It's a type traffic sign. It's using a 3D bounding box to tag that object, and it's using quaternions to define that 3D bounding box. And obviously, as we saw that previously, we can definitely see that object, so it's visible through. And this is just a very, very small subset of the attributes you can use in OpenLABEL. And this is pretty much all I want to teaser before we move on to the next presentation on what role OpenLABEL can play within the whole OpenX family. So there are a lot of connections between all the other standards. And yeah. So next up, Nico, it would be you again. Oh, are we at the? Give me a second.
Yeah, it should be the intro to OpenLABEL
Yes.
structure.
Exactly. So now next up is the introduction and structure